So in this video we will draw the ping pong game. So for that already I have taken the HTML file and some basic HTML and body tag already I have added. So now let's start the coding. I'll take the canvas element, id equal to canvas. Below the canvas element I will take the script tag of type text or JavaScript. Inside the script we'll write our code. So first I need some constant variable for canvas which we can get by document.getElement by id by passing the canvas element id. Then to initialize the width and height we'll take the constant variable of width, and I'll set the width around 400 pixel and the height around 450 pixel. So for the canvas we'll set the width equal to width what we have initialized, canvas dot height equal to height what we have initialized. Now for the background color we'll use the style.background and the color will be wheat, say. Now we'll take another constant variable called context to get the context of the canvas of canvas.getContext. Context today. Yeah, so we'll see in the browser how it's look like. Yeah, perfect. Now first of all I want to draw the pedal, and for the player pedal and the CPU player pedal in the top, and so let's take the function for that. So pedal function I will name pedal, and for the pedal we have to take the x and y position, then pedal width and height. So let's take that constant also. So pedal width will be around 90 pixel, then pedal height will be around 15 pixel. So we'll pass that one, pedal width and pedal height. So let's initialize this property x equal to x, this dot y equals to y, this dot width equals to pedal width what we have passed, then this dot height equal to pedal height. So pedal will have one more property, since when we play the game the pedal will move in the x direction. Both the pedals, CPU player and our number player pedal also will move in the in x direction. So we will take the another property, this dot x direction speed, we will make it in as initially 0. So this is pedal function. Let's draw the pedal now. So pedal dot property dot draw pedal equal to function, and then inside this we'll draw the pedal. So context dot begin path, context dot fill style, the pedal color I want say 00cc00, then context dot fill rect, and then the position will be x, will be the same, this dot x, this dot y, then this dot width, this dot height. Okay, then context dot close path. Yeah, so pedal is done now. Let's take the another function which will inherit from the pedal one. So let's take function player. Inside this it will have the one property called pedal, and it will be new pedal, and for this we have to pass the position. So the player pedal, it will be in the bottom, so the position will be exact at the center, and the width and height will be the same what we have initialized for the pedal. So the coordinates are width by 2, then minus pedal width by 2, it will give me the center position. Then the y position will be the total height of the canvas minus pedal height. Then the same pedal width and pedal height, the size of the pedal. So this is player pedal. Now let's draw the player pedal now. Player dot prototype dot draw player, it will be function. Then inside this already we are having the pedal, and the pedal is using this pedal function. So in this pedal function already we are having the prototype to draw, so that we can call here. So draw pedal, and same thing we will do for the CPU player function. Below we'll put the CPU player function. So function CPU player, and this will have also pedal, it will be new pedal, and the position for the CPU pedal will be in the top, and the same center position we want, and the y coordinate will be 0 here. So width by 2 minus pedal width by 2, and y will be 0, and the same pedal width and height. Yeah, so for the draw the CPU player dot prototype dot draw CPU player equal to function. So this already we are having the pedal as we did for the player, pedal dot draw pedal. So these two are done. So let's create the object of these two, CPU player and the player, in the top. So where player equal to new player, and where CPU player equal to new CPU player. Okay, we'll draw this. To draw, I'll take another function called draw game. Inside this all the drawing of the player or pedal or ball we will be doing here. So player dot draw player, then CPU player dot draw CPU player, and this function will call in the bottom, and later on we'll put that into the loop function. So we'll call in the bottom. So let's see now everything has been drawn in the canvas. Yeah, so this two has been drawn. So now we'll draw the ball at the center of this canvas. Let's take the ball function. So function ball, we want the position x and y, and then radius of the ball. Then we'll initialize the property. This dot y equal to y, this dot radius equal to radius what we have passed. The ball will have other property, since when we play the game the ball can move in the x direction and the y direction, so it will have both the direction and speed. So we'll initialize that also. So this dot x direction speed. So what I want is, I want random x direction speed and random y direction speed. So for that what I will do here, I'll use the math.random function. Random, if it is less than, if the probability is less than 0.5, then I want in the positive direction. So math.floor, then math.random will multiply by 3, so it will give me 0 to 3, and inside whatever result I have I'll add +1, so it will give me result 1 to 4. So that will be the minimum speed will be 1 and maximum speed will be 4 likewise, and if not then we will give the negative direction speed. So same math.floor, math.random, and we'll multiply by same 3, and then whatever result we'll add 1. So this is our x direction speed. Same thing will go for the y also. I'll copy, and this will be our y direction speed. So we have initialized this too now. So our ball function initialization is done. Now we'll draw the ball. So ball dot prototype dot draw ball equal to function. Inside this we'll draw the ball. So we have context dot begin path, context dot fill style. I want different color for the ball. Say I want FF0C00, so it will be around a red color. And then context dot arc function will use to draw the circle, and then later on we'll fill. So the x coordinate will be this dot x, then y coordinate will be this dot y, then radius will be have radius already, then the starting angle will be 0, then finish angle will be 2 times the math dot y, total circle it will draw. Another is clockwise anti-clockwise. It is optional, we can omit, but if not give, then it will take false. So then context dot close fill to fill the circle, then context dot close path. So we have draw the ball now. So let's take this object in the top, get the object of the ball in the top. So here where ball equal to new ball, and position I want at the center of the canvas, so with y2, and height will be height y2, and radius it will be around 5. And for this ball we will draw inside the draw game function, draw ball. So let's see if ball has been drawn here. Yeah, ball has been drawn. So now everything we have plotted. Now we will give the motions. So first we'll start with the ball, and let's create the update function for the ball. Here ball dot prototype dot update ball. Here it will be function. So the position of the ball, we will check with the whatever the player paddle is there. So we'll take these two parameters, so player paddle and then CPU paddle. See, these two paddle will pass here, and later on we'll check the collision happened or not with these two paddle. So that is why we need as a parameter here. So then let's give this speed in the x direction, that will be equal to this dot x direction speed, and this dot y plus equal to this dot y direction speed. Okay, now let's check if the ball has touched the left side of the boundary and the right side of the canvas boundary. So let's give the check if ball hits left and or right side of canvas. Okay, so for that, if what we need this dot x, then minus this dot radius. So means left most part of the ball, if it is less than 0, then position has to be changed. So less than 0, then let me put that into the parenthesis here. Fine. So then the direction we will change, x direction speed will equal to minus this dot x direction speed, and else if this dot x plus this dot radius, we'll put inside the parenthesis properly, if it is greater than the width of the canvas. So means when the rightmost part of the ball, if it is greater than the width of the canvas, then again we have to reverse the x direction of the ball, right? So this dot x direction speed will be equal to minus this dot x direction speed. Yeah, done. So we have checked the left and right side of the boundary. Now we'll check if ball has hit the paddle. Okay, so for that let's check if the same thing, this dot x plus this dot radius, and if it is greater than, I mean to say is when the rightmost part of the ball is greater than the for the player paddle the x position, right? So if it is greater than the we already have passed the player paddle here, so player paddle dot x and this dot x minus this dot radius. So means the leftmost part of the ball if it is inside the x plus width of the paddle, right? So then if it is less than player paddle dot x plus player paddle dot width. If it is less than, then fine, then another condition will check if the y positions, if it is x plus y means y position of the ball plus radius, if it is greater than the total canvas height minus the width height of the paddle. So what we'll do, this dot y plus this dot radius, if it is greater than the total height of the canvas minus paddle height, then ball has hit the player paddle. So in this case what we will do, we will initialize the will increase the x direction speed of the ball by the whatever the speed of the paddle was there. So this so player paddle dot x direction speed divided by 2. Whatever the speed the paddle has, half of that will be added to the direction of the ball. Then this dot y direction speed, it will be reverse this dot y direction speed, and they will add to the y position this dot y plus equal to this dot y direction speed. So this is done for the when the paddle is hitting the player paddle, ball is hitting the player paddle. Now same thing we will do for the CPU player paddle. So I'll copy the same thing till here, and the same this dot x is greater than, and here it will be CPU paddle dot x, and this dot y minus radius CPU paddle dot y dot CPU paddle dot width, and this time the position of x minus radius means topmost surface of the ball when it is less than the height of the paddle, right? That condition we have to check. So this dot y minus radius if it is less than the height of the paddle. In this case the ball has hit the CPU paddle, and in the same thing we'll do, we'll reverse the y direction speed and we'll add the x direction speed with the speed of the paddle. Yeah, so this is done. So let's check and we'll see if it is working. So we will what I'll do, I'll put another function to update the game. Update game. Inside this all the update of the game we will do. So ball dot update ball, and this function will call in the bottom, and let's put this two function inside the loop function. So function loop, and we will put this two function, and we will animate it by request animation frame, and callback function will be the loop, and let's call the loop function once. Fine, so let's see if it is drawing. So we have error, or maybe we'll check. Yeah, so the property x cannot read or undefined. So what position? yeah, so we have to pass the pedal, right, in the update. So we will do that one in the update function here. So let's pass that player.paddle, then CPU player.paddle. Now let's check. And before, one more thing, we have to clear the canvas every time. So when the loop will call, so context dot clear rectangle 0 and total width and height, total full canvas will clear. So now let's see if it is working. Okay, so update what has happened. Extraction speed we are giving. Okay, fine. Create game, request animation frame. We'll clear the canvas. Fine. This is fine. Ball dot update ball we are having. Let's check. We will have x and direction speed. Update function for the ball. This dot x direction speed, y equal to y direction speed. Then check if this dot x is greater than fine radius, then this fine. This dot x plus radius is greater than the fine. This condition also seems correct. Then height, so it will be plus equals the speed of the extraction. Okay, so let's check. So yeah, so it's moving now. We'll see the condition. This is not, we have to check. So this dot x plus radius is greater than paddle player paddle dot width, and this dot x minus radius is less than the paddle x position and then player paddle dot width, correct? And this dot y plus radius, if it is greater than the height minus paddle height, that is correct. If it is true, then it has touched the paddle. If else, this dot x plus radius is greater than cp paddle dot x, and if this dot x minus radius is less than the cp paddle dot x plus cp paddle dot width, correct? And if this dot s minus radius is greater than, should not be greater than, it should be less than, because it should be less than, then only it will come there, right? If it is less than the paddle height, then the direction will be the paddle direction and the y direction will be reversed. So fine, let's see, play this. Fine, it's moving perfect now. Okay, so it's with the random speed in the random direction it is moving now. So now fine. Now what we will do, let's check if the when you can see when the ball is crossing the bottom of the canvas, or it is going at the top of the canvas, then the player is lost. So for that, what we will do, we'll add another condition. Check if ball has missed to hit the paddle. And for that, what we'll do, if this dot x plus this dot radius, and this time this has to be less than the player paddle dot x position, means the rightmost portion of the rightmost portion of the ball if it is less than the paddle, this one, and or so before that I'll put that into the brackets properly. So fine, if it is or, the position of the ball, this dot x minus this dot radius in the means the leftmost portion of the ball if it is less than, so it is greater than the player paddle dot x plus player paddle dot width. Then if either thing is true, so let me put in the bracket. So if it is true, then what we will do, we'll add we'll check the another condition, and that will be the y position. So if what we'll do inside the here, when this one is true, we'll check if this dot y plus this dot radius, means in the bottom then in the bottom, then what we'll do, if it is greater than the width height of the canvas, then it has crossed all the way height of the canvas, then the CPU player has win, right? So since console.log CPU player has win in the game, and we will initialize, and so we will initialize the same component. So this dot x equal to width center of the canvas, will initialize the ball position again to the center, y equal to height by 2, then same direction will be the random, so I'll take this same function here. Okay, so this was for the when the paddle is being missed by the CPU player paddle, and we'll check the another else condition, else if we'll check if this dot x plus this dot radius, if it is less than the CPU player paddle dot x, put into the brackets CPU paddle, or this dot x minus this dot radius if it is greater than CPU paddle dot x plus this dot CPU paddle dot width. If it is true, then we'll check if this dot y minus this dot radius if it is less than 0, then it went till full top of the canvas. So then with same thing, in this case the player will win, and we will initialize the ball position again to center. So player has win the game. Let's check if it is working fine. See, we'll get fine. Yeah, it's starting with the center again, right? Once the ball has missed. Fine. So if you want to see, you can go to the console and see CPU player has win the game, because the player, it has been missed by player. So perfect. Now now what we will do, we'll add the motions to this one paddle. So for that what we will do, let's take the event to the document and start that. So document dot add event listener, and I'll take the event as keyed on, and we write the arrow function by passing the event here. I'll take the arrow function here. Then inside this let's take the another variable, means if we have placed the left button or right button for that. So let's take where is left equal to false initially, then is right equals to false. Okay, next so as soon as if we have placed the key, we'll check if the event dot key code, if it is equal to 37, means it is left key is pressed, then is left will make it to true, then other is right will make it to false, else we'll check if event dot key code equal to 39, means it is right arrow key has been pressed, then is left will be equal to false and is right will be equals to true. So yeah, done. So let's create the another update function. So we have to move the paddle, so let's get in the paddle function first. So we are having the paddle here, paddle dot. So below this we'll create another prototype function, paddle dot prototype dot update paddle. Okay, so then this will be function, and here it will move with some x value, right, in the extraction. So we'll take the x, and what we will do, this dot x we are having the paddle, right? So this dot x plus equal to x, and so we will move with the extraction, we will move the paddle in the extraction with the x value. Now the speed also will be the x only, so extraction speed will be equal to x. Now we'll check if the paddle has moved completely to the left side or the right side. That time we no need to move further, right? So we'll add that condition. If this dot x is less than 0, then this dot x equal to 0, and this dot x direction speed will be 0. I will set to 0 now. Else if the x position plus this dot width not here, it will be in the if condition here. So this dot x plus this dot width, if it is greater than the width of the canvas, then in this case again we will set the x position to total width of the canvas minus whatever the pedal width is. So with then and the extraction speed will be set to 0. Okay, fine. So this is done. If it is moving right side of the canvas, total right, then again the position will be again x, and then speed will be 0. So let's we will call this function inside each of the player and the CPU player function. So let's create the CPU player function first. So player dot prototype dot update player equal to function, and here we'll check if it is left. If it is left, then it has to move in the left direction. So for that we already have this dot paddle dot update paddle right here, and it is expecting the x x value. So if it is we have to move left, then we will pass the negative some value. So say I'm passing 4, so we'll move the paddle with the 4 pixel each time, and then else else if again we'll check is right, then it will move the paddle with positive 4. Okay, so this is done. So let's check if it is working. So I'll just we are having, it's not taking. So let me check what has happened. Yeah, we didn't call this here, right? We didn't call anywhere. So let's call that inside the update function. So we are having here, so player dot update player, and yeah, so we'll call here. Now we'll see if it is moving fine after pressing the, yeah, it's moving, but you will see it is keep on moving to the left till right. So see, it is happening because we are making, once we will press the left button, the is left is true, so we have to add the key up event also. So let's take document dot add event listener, and it will be key up, and here I'll take again arrow function event. I don't need maybe, because I have to just initialize the is left and is right. So is left equal to false, and is right equals to false. So yeah, let's check if it is fine. Yeah, it is working when I'm pressing. Okay, perfect. Okay, and now let's move the CPU paddle. So for that, what we will do, we'll below the CPU update CPU drop player function, then there will take another function CPU player dot prototype dot update CPU player, and it will go to function, and for this we will move automatically, and it will be with the position of the ball. So what we'll do, we'll pass the ball as a object here, and we'll check let difference between the position of the center position of the paddle and the ball equals to. So for that, what we'll do, we are having this dot x plus this dot width by 2. It will give me the exact center of the center of the pedal. It means it will give me this position at the center, and from here we'll compare the the distance between the ball. So if it is, then minus ball dot x, so it will give me the difference. So let's take negative difference of that. We'll add one more parenthesis. Yeah, so this will give me the difference between the center of the paddle to the ball x position. If it is negative, then we'll check if the difference is less than 0, that's true, and if the difference is less than some value, say random value 4, then we have to move the CPU player paddle in the with some value, right? So we'll take difference values to minus, say 5, with 5 pixel will move. Else if this dot x if else diff is greater than 0 and difference is greater than 4, then this time we'll pass the difference with the, we will we'll remove the paddle right side with the 5 pixel. So let's call that this dot paddle dot update paddle we are having, and this time we'll pass the difference. So what we did here, we checked the relative difference between the center of the paddle with the ball x position, and if it is in the left side, then we are moving paddle to the left side. If it is in the right side, then we are moving paddle to the right side with the 5 pixel. We have initialized here, so it will move with that. So, and we'll call this function inside the our update function here. So we have the update function, Yeah, so CPU player dot update CPU player, this one, and we will pass the ball object here. Fine, so we did. Let's check if it is working fine. We have error, CPU pedal is not defined. Yeah, we ticked the wrong one, so it should be CPU player. Okay, let's check. Oh, so something uninitialized value we are getting. Upgrade the CPU player with the ball. Where is the CPU player here? If it is update pedal, difference equal to 5. Yeah, this dot width, no, not this one, this will be pedal, right? Pedal dot width, and this will be pedal dot x, correct? Yeah, fine, it seems fine now. Yeah, so see, it's moving with the relative position of the ball, and here we are having the another. So this is the game, and thank you guys for